In this video, we're going to be looking at using similar triangles. So just a little review for them to be similar. Remember, they have to be the exact same shape, just different sizes, but those different sizes need to be proportional. So what we're going to look at today is not only just reviewing and understanding what it takes to be similar triangles, we're going to identify them based on their angles today, and then we're going to be using what's called indirect measurement to be able to find missing lengths of similar triangles. So, first of all, what we're going to look at are the angles. So, there's a theorem called the angle-angle theorem, and I'll just shorten that to AA for short. But what this says is that if you are given angles in a triangle, they will be similar if they have two pairs of angles that are congruent. And you should realize that if two of their angles are the same, then automatically the third one has to be the same as well. So for them to be congruent, for them to be similar, they have to have at least two pairs of angles that are going to be congruent. So you may want to take a minute and get this written down before we move on to the next thing. Okay, so if we look at this example and go ahead and sketch these two triangles down and label them, we have triangle ABC, the smaller one, up top, and then we have triangle DEF down here, the larger one. So I haven't given you any of the sides. The only thing I gave you are the angles. So on ABC, angle A is 65 degrees, angle B is 95, and angle C is 20. And then down below, angle D is 65, E is 95, and F is 20. So the question we are going to ask on this is just simply going to be, are these two triangles similar, and how do you know that? So remember, based on the angle-angle theorem that we were just talking about, for them to be similar, they have to have at least two pairs of angles that are congruent. So I realize automatically that all three of the angles are the same for both triangles. So yes, these would be similar. And for our explanation, we're going to say because their angles are all congruent. Okay, if their angles are all the same, then they will be similar. All right, let's look at the next one here. So again, I have two triangles. One's just been rotated a little bit. So this triangle over here on the left, we have an angle labeled as X, an angle labeled as 75, and an angle labeled as 50. And then on the other one over here, we have an angle labeled as Y, an angle labeled as 75, and an angle labeled as 50. So again, we're looking at, are these two triangles similar? So based on their angles, how many angles do they have in common? Well, they both have a 75, and they both have a 50. Now, we don't know what the third angle is, the X and the Y, but just based solely on the fact that they have two angles that are congruent, they are going to be similar because they have two congruent angles. Now, because they have two angles that are congruent, I could go through and figure out what X would be and what Y would be, but I don't even have to do that to know that they're both going to be the same, because remember, your angles in a triangle have to add up to 180, so whatever these both are, it's got to get these triangles to equal 180, and since the other two are the same, the third one's going to be the same. All right, so let's look at one that's a little bit different here. Okay, so same question. We want to ask ourselves, are these two triangles similar or not, and then explain. So on the bigger triangle, I have angles labeled as X, 54, and 63. And then on the smaller one, 63, 63, and Y. So as I look at it right now, they only have one angle in common. They each have a 63. Now that's not enough to know if they're going to be similar or not. So what I need to do is I need to figure out, okay, either I need to figure out X or I need to figure out Y. Doesn't matter which one, but if I figure out that X is also 63, then that's two angles that are congruent, so they would be similar. I could also figure out Y, and if Y ends up being 54, then they would be similar. It doesn't matter which one you do. You could do either one. So let's just figure out X for right now. So let's see here. On this bigger triangle, remember they have to add up to 180 degrees. So I have X, I have 54, and I have 63, and they all have to add up to 180. So I can combine my 54 and my 63, and that would give me 117. And then I'm going to subtract 117 from 180. So that would give me 63. So X is 63. So now I see that each triangle has two angles that are 63 degrees. So I don't even have to do the math. I can automatically know that Y would then have to be 54 degrees because the other two angles are the same. So to answer our question, are these two triangles similar? Yes, they are, because they both have two angles congruent. And really, you could say that all three of them are congruent, because if two of them are, then all three will. So either explanation would be fine for that. All right, now, looking at this one. So what I've thrown in for these two triangles is I've thrown in some right angles. So remember, even though it doesn't say that these are 90 degrees, remember anytime you see that little box, that means that they're 90. So we'll have to take that into consideration. So just looking at it right now, they both share a 90-degree angle in common. So they've got one angle in common. But I need to figure out, do they have two in common? Okay, so on the smaller triangle, this one's got an angle of 42 degrees. So if I can figure out that Y is 42, then yeah, they'll be similar. If Y is anything other than 42, they will not be similar because they don't have the same angles. Same thing, I could figure out if X is equal to 38, they would be similar. So again, it does not matter whether you solve for X or whether you solve for Y. It does not matter. Take your own pick, whichever one you prefer. So let's solve for Y this time, since I did X on the one before. So I'm going to work in this big triangle over here on the right. So I have Y plus 38 plus 90 has to equal 180. So I can combine my 38 and my 90. So let's see, that would give me, Y plus 128. Let me erase that so that doesn't get too confusing there. Okay, Y plus 128 equals 180, and then I will subtract 128 from 180. So I get 52. So Y is 52 degrees. So now looking at it, they both share the 90. But on this big one, I have a 38 and I have a 52. And neither one of those are equal to this 42. So they really only share one angle in common. So are they similar? No. And for our explanation, I'm going to say because they only have one angle in common. All right. Now we're going to switch gears, and instead of looking at angles, now we're going to find the missing sides of similar triangles. And we're going to use something that's called indirect measurement. And what that is it's measuring something without actually measuring it. So you'll kind of see what I mean in just a minute. But so we're going to be figuring out missing side lengths. They'll give you a few of the sides. You have to figure out what X is or something along those lines. So we've done this a couple times so far, but right here, I'm going to tell you exactly what you need to do. We're going to have to set up a proportion, and then we're going to cross multiply. So again, this shouldn't be a totally new concept for you. So let's look at first example. Okay, so this picture is a little bit kind of hard to see, but we have a river basically going through land, and you've got this little guy down here, and he's looking to cross the river. And so what we're trying to figure out is how far across the river is it from where he's standing straight across to point D. So I have two separate questions here. First of all, I want to know is, are these two triangles similar? So what I want you to see is you have two triangles. I have one right up here, the bigger one, and then I have the smaller one that's got the guy standing there. Okay, so we have triangle ABC up top, and then triangle CED right down below. So are they similar? So let's try to figure out the angles. Well, the first thing I notice is that they both have a 90-degree angle. So that's one angle that they have in common. Okay, let's look at another angle. Well, angle A right here and angle D, I don't know for a fact if they are congruent or not. So I really can't tell from those. But one thing that we have discussed, let me draw this diagram really quick to kind of remind you. Remember when we had these diagrams with the parallel lines cut by a transversal? And we numbered them. I'm just going to number these first four. But let's say angle 1 was 100 degrees. Okay? Do you remember that the angle directly across from it, in this instance, the 4, angle 4 was also the same? So angle 4 was also 100. So that's going to be the same case right here. These two angles are right across from each other. So it doesn't matter what they are, they have to be congruent. So we have the 90-degree angles, and then we have this angle C right here in the middle that we know they are congruent. So to answer the question, are these two angles similar? Yes, they are. And then again, I will just, for my explanation, they have two angles congruent. Okay, so now our second question is to find the value of X. So if you see, angle X is right down here, right in the middle of the water. So what we're going to do is set up a proportion. So I have two triangles. So remember, my first fraction is going to come from one triangle. My second fraction is going to come from the other triangle. So let's use triangle ABC first. Okay, well, the only two numbers they gave me are 60 and 50. And it doesn't matter what order you put that in for the fraction. Let's just say I do 50 over 60. Okay? Then, for triangle CED, we have to be careful that we pick sides that correspond. So I have X and 40, but I've got to be careful to put them in the right spot, I guess. So if you look, your 50 and your 40 are going to line up, are going to correspond with each other, I should say. So I need to put my 40 straight across from the 50, and that means my X will go right across from this 60. Okay? And then to solve this, we just cross multiply. So 50 times X is 50X equals, and then 60 times 40, well, 6 times 4 is 24, and then I have 2 zeros from the problem that I need to add on. And then to get our answer, I just need to divide by 50. So let's work this out real quick. 50 goes into 240 4 times. That would put me at 200. I have 40 left over. And bring down a 0, and 50 will go into 408 times. So X is going to equal 48. So that means that the distance across the river there is going to be 48 feet. Okay, so a lot of times when it comes to problems like this, it really helps to have a picture associated with it to kind of help you understand it a little better. So this last example that we're going to do, I'm going to show you exactly how to set up a picture. So it says a person who is 6 feet tall casts a 3-foot long shadow. So remember, your shadow's on the ground. So if I'm going to draw this, I have a person, my lovely stick person here, okay, and they are 6 feet tall. And then they cast a shadow along the ground that is going to be 3 feet long, okay? And then you have a nearby tree. It's a pine tree, so it looks like a Christmas tree. My lovely artistic skills here. So this tree is going to be, it says nearby pine tree. Oh, pine tree cast a 15-foot shadow. So the shadow is 15 feet. And we want to know how tall the tree is. So that's going to be my X. So as I set this up, I'm going to have the person be one fraction, and I'm going to have a tree be the second fraction. So my person was 6 feet tall, casts a 3-foot long shadow. The tree, I don't know how tall it is, but it cast a 15-foot long shadow. So there's my proportion, and to solve it, we just need to cross multiply. So 3 times X is 3X, and 15 times 6 should be 90. And then we just need to divide by 3. So X is going to equal 30. So that tree is 30 feet tall. Now, I know a lot of you may have realized that right to begin with and thought, oh, well, the guy was 6 feet tall and his shadow was half of what he was. So we could kind of use that to kind of figure out, okay, the tree, well, his shadow was 15 feet long, so the tree's got to be 30 feet because it was twice as tall. But they will not always work out evenly like that, so I wanted to get that extra practice in with setting up the proportion. So with this, we looked at knowing if two triangles are similar based on their angles. So remember, they have to have at least 2 of their angles be the same in order for them to be similar. And then we looked at finding different lengths based on if they're similar or not. So we used indirect measurement, setting up the proportions, and then cross multiplying.